So Governing Algorithms, the Politics of Data and Decision-Making is the title of our lecture series, which we are launching today. It's a lecture series organized by the research group Governance of Digital Practices, and it's my utter pleasure to warmly welcome you to this lecture and also to introduce you to the lecture contents today. So I thought I could give you a number of very topical problems associated with algorithms, the politics of algorithms, controversies around algorithms. I could give you some example perhaps from tracking apps, from location services, from perhaps algorithmic management in the gig economy that we've all been using since COVID. I could speak about the various privacy and data scandals that have surrounded social media platforms, the Cambridge Analytica and Facebook scandal, for instance. I could speak about Twitter and its algorithmic curation of information and news sharing and potentially misinformation, the ban of Trump and so on. We could mention the social credit scoring system that is sort of infamous, that the Chinese state is currently using in some parts of the country to partly surveil the population, but also provide sort of disciplinary effects for social behavior. Or we could talk about PageRank, or all sorts of very topical and very pressing issues. I'll do none of that, and I'd ask you to take a few steps back with me and go back a few decades, indeed, back into the Cold War era of the 1980s. And I'm sharing with you the picture of a person who played a very critical role at the height of the Cold War. May not be known to some of you. Maybe if you have a background in history or in political science, you might have heard of him. The name of this gentleman is Stanislav Petrov, and he had a very sort of delicate and critical role in handling a missile alarm in 1983. He was lieutenant colonel in the Soviet air defense forces, and Petrov was an officer in the command center of a nuclear early warning system that the Soviet Union had built. It was satellite-based, so satellites in orbit around the Earth surveilled the Earth for potential nuclear attacks, especially from the US, of course. So they were watching out for any sort of data that could suggest intercontinental missiles being fired. And one day in September in 1983, Mr. Petrov was sitting in this bunker in Moscow, working with that nuclear early warning system, and he got an alarm. And I'll just very quickly give the voice to Petrov himself, and he'll recount what happened in those agonizing minutes that he had to interpret this computerized information.
It was completely unexpected, as such things usually are. The siren sounded very loudly, and I just sat there for a few seconds, staring at the screen with the word "launch" displayed in bold red letters. A minute later, the siren went off again. The second missile was launched, then the third, and the fourth, and the fifth. The computers changed their alerts from launch to missile strike. There were no rules about how long we were allowed to think before we reported a strike. But we knew that every second of delay took away valuable time that the Soviet Union's military and political leadership needed. And then I made my decision. I would not trust the computer. I picked up the telephone handset, spoke to my superiors, and reported that the alarm was false. But I, myself, was not sure until the very last moment. I knew perfectly well that nobody would be able to correct my mistake if I had made one.
Честно говоря, 50-50. Я понимал отлично, что меня никто не поправит.
All right, so that's Mr. Petrov's account of the situation. September 1983, the height of the Cold War. A lot of hostile politicking going on between the Soviet Union and the US under Reagan, and Mr. Petrov sits in the bunker and gets a missile alert. And that's the first time that the early warning system had triggered that and had indeed interpreted data from the satellites to be the launch of an interballistic or multiple indeed interballistic missiles from the US. And Mr. Petrov decided that this was potentially a false alarm, but he wasn't sure about that. So to put it in abstract terms, what we have is a situation where we have some sort of input, in that case, data from a sensor, from sensors that are part of a satellite system that the Soviet Union had launched. And these sensors collect data and send it back to some ground station in Moscow. And in the ground station in Moscow, there's some sort of computer device that runs an algorithm. And this algorithm classifies the data from the satellite. And it classifies the data essentially into, is this a missile attack or is it not? If it is a missile attack, it creates an output, and that output is the display of an alert. And we just heard Petrov mention that. There's in bold letters the word launch and then the word missile strike. And from that time on, the clock is ticking, and there's essentially 30 minutes to ponder immediate retaliation. The protocol that this whole technical device or procedure is embedded in, it says any missile alert has to be reported to superiors. And this is where Petrov says, no, he doesn't do that. He's making a judgment call, and he's actually overstepping the function or the role that has been assigned to in this military command chain. So with a system of automated interpretation of data, of satellite data, these data happen to be faulty. So Petrov happens to be right. It turns out that due to some sort of unexpected cloud constellation in combination with the orbit of the satellites and in combination with a specific constellation of the sun, this triggered data that the algorithm misclassified as missiles. And what Petrov decides to do is sort of override this information or this interpretation. He says this interpretation is probably, hopefully, wrong. So what seems to be the case as well here is that there's no automated decision making, right? So you could have a system which doesn't need a Petrov in place and which immediately triggers a retaliation response. That wasn't the case here. Thank goodness, one should say. So the lesson I think here is algorithms matter. If it is the case that potentially a World War III was averted by questioning the results of an algorithm, this should suggest to us, I think, that as social scientists certainly, but really as anybody interested in important social and political phenomena, we should be interested in the workings of these devices. The lesson is also humans matter as well, right? And the lesson is not necessarily, the takeaway is not necessarily that humans should always be able perhaps to override the information that a computer system has as an output, or that this always creates a better outcome. So think back of, I could have given you a different example, think back of the Chernobyl disaster. It was exactly the other way around, if you will. We had a computer system that had multiple safety mechanisms in place, and experts deliberately, or engineers, supervisors in the plant, deliberately ignored signals and deliberately overrode, again, this information, but with a detrimental outcome, right? So they made a judgment call as well to an extent, and the judgment call was wrong. All right, so that is history. That is the sort of history 40 years ago, Cold War history to an extent. 40 years later, in the present, we are seeing that algorithms of some form have become pervasive, and that indeed ever more live domains outside nuclear energy, outside weapon systems, have gotten or are getting algorithmized. We've seen the rise of internet-based services and what has been termed the Internet of Things. We're seeing the rise of big data. We are seeing advances in artificial intelligence and machine learning. We are seeing the rise of robotic systems in industrial manufacturing and beyond, of autonomous systems. Think of self-driving cars and beyond. The city of Vienna is just building its first automated or autonomous underground railway system. So our age has been termed by some, maybe it's exaggerated, maybe not, as an algorithmic age, as an algorithmic culture that we live in, maybe even as an algocracy, so as the rule of algorithms, or as being characterized by the rule of algorithms. And we think, as a research group, that understanding these phenomena is important and is an important interdisciplinary endeavor. And hence our lecture series, that's the motivation for it. All right, so let me give you a bit of an overview of that paper by Michael Latzer and Natascha Just, who are based in the University of Zurich. And the background is in communication science, media studies. They published an article 2 years ago on governance by and of algorithms on the internet, impact and consequences. And I think it summarizes nicely some of the key debates, and is a good sort of introduction into the various themes and concepts that we'll be using and drawing on in the lecture series. But by all means, this is one way of framing it. These are communication scholars. The article is focused mainly on algorithms on the internet, not algorithms in the Cold War. I think they will be widely usable throughout the sessions that we encounter in the lecture series. All right, let's start with the question of what the heck is that thing, algorithm, even? And that is quite a tricky thing to answer indeed. And perhaps Claudia Blunt will also be able to share some light on that in a week's time. But let me start with a very broad definition that is provided by Latzer and Just, and they draw on some other names as well. But as a disclaimer, there are very different definitions and perhaps even contradicting definitions and meanings of algorithms. Some of them very wide, all-encompassing almost, very abstract, some of them very concrete, very technical. Latzer and Just tell us a broad definition of algorithms could be made as them being problem-solving mechanisms. They think that's a sort of appropriate approach, problem-solving mechanisms. A common feature, they say, of such problem-solving mechanisms on the internet are automated algorithmic selection processes, which can be defined as the automated assignment of relevance, to selected pieces of information. Okay, think back to the case of Petrov as well. This is an automated assignment of relevance to sensory data from a satellite, right? Relevance meaning this is a missile or it isn't. Further, these algorithmic selection systems can be described as input, throughput, output systems, okay? So we had that figure of thought already introduced a few slides back. Input, data input mainly, throughput, some sort of calculation or mathematical device, if you will, output, some sort of decision perhaps, or provision of information. Small or big data could form the input into such a system, and various algorithms, for instance, a search algorithm, a filter algorithm, a prognostic algorithm would form the core of the throughput phase, okay? So input, throughput, output, which with the goal of automatically assigning relevance to information, to selected pieces of information, and the purpose of all of it is sort of problem solving exercise or device. They also make reference to Gillespie, who defined algorithms as encoded procedures for transforming input data into desired output. So again, that metaphor of input-output, and perhaps with the added connotation that what happens in between the input and output could be something of a bit of a black box, based on specified calculations, is what Gillespie says here. So encoded procedures. Okay, Latzer and Justin tell us they get a bit more concrete. This is a highly abstract way of defining an algorithm. They say there are precise areas of application, particularly on the internet, of what algorithms there are or what they do. Number one is search. Algorithms search for information. So think Google and any sort of content search that you use on a daily basis as an internet user. Aggregation of information, okay? So putting together in a coherent manner information from different places and aggregating this information or aggregating data into bigger classes. Observing and surveilling, observation and surveillance, it's another sort of application of algorithms. The Petrov, the missile early warning system is of that kind. It observes from the orbit, it observes the Earth, it surveils it and collects data about what is happening in the atmosphere, and then assigns relevance to that data. Prognosis and forecast, so what will happen based on historical data, so extrapolating trends, extrapolating essentially statements about the future from existing retrospective analyses. Filtering is another area of application for algorithms. So that is overlaps to a degree, of course, with search, also with observation, also with aggregation, but filtering exercises, dividing between what is relevant, what is pertinent, what is applicable, what is useful from things that are not useful. Recommendation, that is also something that you encounter as an internet user on a daily basis, especially in online commerce, in dating, in all sorts of an ever expanding set of contexts. You may also be interested in this or that. You may like this or that based on your previous behaviors, on your previous decisions or purchasing behaviors, whatever. Also, in a sense, a sort of prognostic or forecasting algorithm that is at the core of that. Scoring, we mentioned the social credit score very briefly, Chinese approach, but of course scoring algorithms are in universal use in a sense, the page rank is a sort of scoring of relevance to different information that is scraped from the web. Content production, that is interesting, perhaps a not so typical or not yet so typical function or domain of an algorithm. So actually not filtering or reducing or aggregating or prognosticating existing content, but producing it, adding to content to a degree. Think of things like social bots, think of algorithmic journalism, and so on. And allocation is another feature or domain application of algorithms. So allocating resources, think of the AMS algorithm potentially informing the decision-making about allocation of financial resources, for instance. Okay, these are 9 areas that, again, we're still quite abstract here, 9 areas of application. And Latze and Just tell us that there are different sort of ways, frameworks, philosophies, you could say, of studying algorithms in their context of applications. 2 big sort of paradigms. They're not mutually exclusive necessarily, but they're perhaps, there's a point in clarifying them or differentiating between them. So they say you could study algorithms in isolation with the purpose of uncovering its inner workings, sort of what's under the hood, open up the black box, look into it, review the code, reverse engineer the code, see what it does, audit what is in there, uncover the inner workings, show what it's capable of doing in different situations, maybe experimentally testing that, does it behave in intended ways or in unintended ways, and so on. Okay, so that is the sort of narrowly focused study of algorithms in isolation. And we could distinguish that from a different paradigm that studies algorithms in their social, socio-technical context, right? So if we would like to stay in that metaphor, sort of not looking into the hub of the car or into the inner workings of the car, but the car in its context, in the traffic system, embedded in rules, behaviors of humans, of other algorithms, of infrastructures, of resources, and so on, of values of institutions. So the second approach would study algorithms in their socio-technical context of application, integrating algorithms. And here we're introducing some language that is especially prevalent perhaps in science and technology studies. We could study algorithms as situated artifacts or generative processes embedded in an ecosystem, right? So an ecosystem metaphor, or algorithms being considered as a component in a socio-technical assemblage, or comprising technical and human components to sort of as a minimal consensus, right? So in a sort of relational, studying them in a relational way. This will be mainly or exclusively in the approach that will be taken in this lecture series. We are not software engineers, and our interest is in not so much in the inner workings from a technical point of view, but in the social ramifications, impacts, governance questions surrounding the use of algorithms. Okay, Latze and Just, and that is an important distinction, at least for a start, I'd say, and could always be complicated or made more complicated later on. But for a start, I think it's a meaningful distinction. They distinguish between governance by algorithms and governance of algorithms. Okay, so in our lecture series, we have this title, Governing Algorithms, and it's a bit double-edged or multi-interpretable, if you will. Could mean algorithms are governing society, us, but also we are governing algorithms. And this is exactly the distinction that Lutz and Just are getting at here. Governance by algorithms, governance of algorithms. Let me briefly say something on this distinction. So governance by algorithms, or if perhaps in this sort of, in terms of research, you could say algorithms as a sort of independent variable. How do they define governance by algorithms? They say we're speaking here of the operating modes and mechanisms of how algorithmic systems influence social and economic processes and their multifaceted effects on society, how they can analytically be conceived of, or this can be analytically conceived of as governance by algorithms. Okay, so you think there is something like an algorithm, it has influence on social processes, economic processes, political processes, and so on society. It makes an imprint on society. Questions that would be raised in that framework or in that paradigm of governance by algorithms would be something like, are certain algorithmic applications designed to augment or to replace human decision making? Think back again on of the example of Stanislav Petrov, right? Actually more of an augmenting algorithmic application rather than replacing. He was, thank goodness, not replaced by an algorithm here. Are algorithms used by humans purely as fully controlled tools to govern, or are they designed to govern autonomously as agents? And if so, to what extent, right? This may not be a completely binary situation, either autonomy or tool character, but there could be complicated things in between, perhaps. What may be the unintentional effects of algorithmic governance, and so on. These are the kinds of questions you could be asking or raising in this framework. So governance by algorithms. So let's continue a little bit in that framework. So what Lutz and Just tell us is the effects of governance by algorithms could be framed as shaping and influencing individuals' reality construction in everyday life. This is what it boils down to on the perhaps most abstract level. So algorithms would somehow be implicated in shaping individual reality construction. People construct a social reality, and algorithms play a role in that. And consequently, they play a role in forming social order in digital societies, right? So in societies where algorithms are prevalent, these algorithms would be implicated in forming sort of social order and a shared social reality. A shared or even divided social reality, potentially. I'll say something about that in a minute. And they say this algorithmically co-shaped reality construction differs from the conventional reality construction by mass media, for instance. So we see their interest in the communicative media aspect in the study of algorithms. And here they are especially concerned with, particularly with personalization, for instance, and with the constellation of actors involved. So what's the kind of topics that are researched in that area? For instance, research on impact of algorithmic governance on social and political orientation, right? The impact of search algorithms, of algorithmic curation of news, of algorithmic content creation, of social bots and things like that. And there are various concerns that you could see in the literature about, for instance, the spread of misinformation, about so-called echo chambers, so-called filter bubbles, potentially a fragmentation of the opinion landscape, and so on. All of these things are highly debated, right? So there are concerns about this. None of this is necessarily consensual, or there's no sort of fully fledged consensus about these things, even on the question if echo chambers exist. Interesting. Mr. Zanko, big data news tutorials for Facebook, Instagram, and WhatsApp down. Okay. All right. The domain of recreation, right? So outside social and political orientation, we'd have devices like wearables, like tracking devices, self-tracking, tracking in sports and so on, medical tracking. The various applications and devices in this domain give rise to a host of issues, problems, and again, concerns to do with perhaps diminished diversity, sort of self-selection into, again, certain behaviors, certain social groups, or indeed the algorithmic shaping of culture that may or may not be problematic. And another domain that they list, and this is not an exhaustive list, but these are some areas where research is ongoing, is the domain of commercial transactions. So the whole range of recommender systems, attention tracking, targeting, so-called micro-targeting, the effects of that or non-effects of that, and so on. And here again, concerns about diversity, control, manipulation of behavior, and so on. A whole area of vibrant and controversial research. I should note, and it's an interesting sentence that Latsand used write sort of in passing, and where they say, well, it's interesting, literature on the benefits of algorithmic systems is a bit scarce, as a sort of yeah, they concede there's a bit of a negativity bias, it seems. And that's something that I'd like you to perhaps to an extent keep at the back of your minds as well, also during our lecture series to a degree, right? As social scientists, we tend to be problem oriented, and very often sort of implicitly we take for granted, of course, algorithms do things like bring convenience, bring efficiency, bring an abundance of information, cut prices, have huge sort of scale and efficiency effects and so on. But, and then comes the exploration of what kind of problems is it creating: misinformation, chambers, diversity, discrimination, manipulation, and so on, control, the various power relations involved in that. Okay, so just keep in mind that we're not sort of, the purpose of this lecture series is certainly not to trash technology or anything of that sort, or to only promote a sort of a dismal view of technology, but we are naturally sort of problem oriented. Okay, so this is the paradigm of governance by algorithms, and I've promised you the mirror image of that, or yeah, the other side of the coin, governance of algorithms. So algorithms as the dependent variable, to put it again in a sort of research design terms. Governance of algorithms, what could that mean? Again, as a means of a definition or an introduction, what Latsand used to say is this refers to various practices of control, to control, shape, regulate algorithms, and the effects that result from their processing, learning, adaptation, and or decision-making powers. Okay, any practices, social practices, legal practices, political practices to control algorithms, to shape algorithms, to be involved in the design, to participate in how they work, whether they are used at all, and so on, to regulate them, to regulate the consequences of using them, and to regulate, as it says here, the effects that results from their processing, learning, adaptation, decision-making. So all issues revolving around also liability. What does this do to society, and who can be held accountable, and so on. Right, that's the governance of algorithms. And here we're sort of stepping outside again. Think back to that metaphor of the ecosystem, or the embedded metaphor of algorithmic governance, stepping outside of the narrow technological frame, and we consider algorithms in their social contexts, values, goals, political goals, legal practices, the law, human decision-making, institutions, political institutions, and so on. And we already had a good example of how an algorithm, an early warning algorithm in the case of Petrov, is embedded in a social context, is interpreted, its outputs are interpreted by humans, it's embedded in a protocol, in a command chain, and so on. And of course, its design and so on was also socially shaped and politically shaped. Okay, so let me conclude this part on the governance of algorithms with 4 approaches that Latzo and Just tell us are important, pertinent in the governance, in the discussion of the governance of algorithms. And they say there is the risk-based approach to algorithmic governance. There's the human rights-based approach. There's the ethics-based approach, and there's a set of principles-based approaches to governing algorithms. And I'll spend just a few minutes on this to explore what each of these approaches mean. So first of all, risk-based approaches. As a big discourse and a big sort of sector in partly the academia, but also policymaking and the experts that inform policymaking, have to do with controlling the risks associated with certain types of algorithmic applications from a public interest perspective. Okay, so what kind of risks may the application of or the use of an algorithm pose in the way it is designed? Think back perhaps to, well, the AMS algorithm is a good case for that, or the various algorithms that were used in the context of COVID-19 pandemic management, right? So systematic risk identification, what could this do in case it's misused, or are there unintended consequences? What can we assess the risks for privacy, for the social acceptance of technology, and so on? What are some of the issues that Latzo and Just say are at the core of this risk-based approach paradigm? Issues around manipulation of the society through the use of algorithms. Think of, for instance, the spread of misinformation on the internet. Again, diminishing variety, diminishing diversity, the creation of biases, distortions in social reality. Constraints on the freedom of communication and expression. So think of various censorship algorithms, for instance. The Great Firewall would be a sort of example of that, and the involvement of various tech companies in that. So filtering out certain contentious political information, for instance, from social media, from fora on the internet, from and so on. Data protection, privacy concerns, social discrimination concerns, violation of intellectual property rights concerns. So, well, Turnitin perhaps is something along those lines. Abuse of market power, and so on. Possible transformations and adaptations of the human brain and the uncertain effects of the power of algorithms on humans. For example, growing independence of human control. That's one of the worries that sort of algorithms, or that big sort of domain of worries where researchers are worried that we don't really understand the workings properly enough of certain complex learning algorithms. They could have unintended consequences. They could develop almost an agency on their own. They might get out of control. We may put in commands that backfire and so on. So there are various discussions around that sort of loss of control, or on the other hand, a growing human dependence on algorithms. Sort of we need the phone, we need certain data resources, certain algorithms. We can't live without them anymore. Society may not work properly without them anymore. I don't know, the electric grid may collapse without certain algorithmic management and so on. So these are risk-based approaches, and you'll see some of these worries, concerns mentioned here will reappear in the other approaches as well. As a second domain, Latze and Just mentioned human rights-based approaches. Where do they differ? Well, they discuss the power and impact of algorithms in light of specific human rights concerns that may be affected by the operation of algorithms, and we'll have some focus certainly on this kind of paradigm throughout the lecture series, especially from our colleagues from the Department of Law. Arguments grounded in principles and normative justifications underlying certain legal frameworks that may be human rights frameworks or indeed other rights or constitutionally granted rights. What's interesting is these tend to center more sort of on individual and on the individual and his or her rights that may or may not be violated, perhaps, or harmed by the results of algorithmic procedures. Examples that Latze just mentioned here: credit scoring, right? So if I Google your name and some information pops up that you are potentially a bad person to grant a loan to or something like that. This could be quite damaging in terms of your creditworthiness. Health diagnostics, similarly, there are internal concerns about the use of health data by employers, for instance. Criminal risk assessment, similarly so. So issues such as, that's again a non-exhaustive list. There are many more issues at stake here. Issues such as fair trial, due process, privacy, data protection, freedom of expression, assembly, association, and so on. These are concerns that are salient in the human rights-based approaches. Moving on, ethics-based approaches, the third of the three sort of paradigms that are strong in the governance of algorithms framework. In a nutshell, they focus both on epistemic and on normative concerns. With regard to the epistemic concerns, there's a range of worries around the quality of evidence produced, right? Is this reliable information about missile attacks, for instance, would be a worry about the quality of evidence. Is the information reliable? Is it conclusive? Is it inscrutable? Do we even understand the information? Is it misguided? Is it biased? Does it lead to unjustified actions, right? Does it lead, for instance, to unjustified retaliation measures, military retaliation measures? Is it opaque? Is it biased? And so on. Issues pertaining to the evidence generated by algorithms. And another sort of domain of concern here are simply normative concerns relating to the action of algorithms, not so much or not necessarily narrowly on the evidence they produce. So do they produce unfair outcomes, for instance? Do they lead to discrimination, to effects transformations that are unintended or that are ethically problematic? And the final sort of overarching concern is traceability. So can we even trace back outcomes, consequences to the use of algorithms? Or is this a very sort of, do they play a very obscure or hidden role? Okay, and Latze just give us, for instance, the example of automated journalism. Final point on this, principles-based approaches, and I'm very close to wrapping up and to starting the Q&A. Principles-based approaches, that's sort of an eclectic collection of various, ethical principles or policy principles that are salient in various policy discourses. So these are issues around, for instance, the accountability of agents involved in algorithmic governance, right? Can we trace back, can we hold somebody liable for for designing an algorithm or using an algorithm or feeding an algorithm with certain data. The transparency of algorithms is there a case to be made for certain algorithms to be, I don't know, information about it being in the public domain, fairness, liability, justification. And they say, well, these are sort of eclectic things. There's not a systematic framework necessarily, but these are important principles that are not necessarily embedded in a sort of grand normative theory or big normative framework, but nevertheless, they come up ever again in policy discourses, issues like transparency, as I just said. Okay, these are the 4 approaches that they mention in the context of governance of algorithms. And they conclude the paper with a sort of an afterthought on these 4 paradigms. And they say, well, actually what we need is a sort of a way to choose between these different modalities of governance of algorithms. How do we know when to use sort of a command and control regulation? Certain algorithms should be, I don't know, prohibited perhaps, or on the other hand, sort of should just be dependent on a sort of free market approach, privately governed. People may not be forced by state authorities to do anything with algorithms, but to voluntarily perhaps disclose some information about them or not. So that's the sort of ingrained tension between these different paradigms, how to choose between them, what mode of governance is appropriate to manage or to govern algorithms in different domains, right? And we could think of these governance paradigms or governance modalities to be quite different. For instance, if you have a missile system with that triggers a military response, retaliation response, the governance of that might be quite different from perhaps the governance of a learning algorithm in a scientific project or something like that. So what we need, Lutz and Just say, is a sort of governance choice method. And that's it for today, essentially. I hope this was a sort of bit of an intro into the thinking of algorithms, and we'll continue that over the next sessions.